Hello dear students. In our earlier lectures, we have discussed about the Dalton's atomic theory and we have also seen the usefulness of Dalton's atomic theory, or you can say the importance or significance of Dalton's atomic theory, because Dalton's atomic theory has provided us some very useful, valuable informations about the atoms. The one biggest achievement of Dalton's atomic theory was that it could very well explain the laws of chemical combination that were given by Proust and Lavoisier on the basis of the experiments that they have performed. So these laws were very well theoretically explained with the help of Dalton's atomic theory. Another idea which we got from this theory was, according to Dalton's theory, we have seen that atoms of same element are similar in all aspects, as they have got same atomic masses, shapes and sizes, and atoms of different elements have different properties, like they have different shapes, sizes and atomic masses. So by looking at the usefulness of the Dalton's atomic theory, other scientists were prompted to calculate or to measure the atomic masses of elements. When they saw that it was clear that as atom is a matter and matter is having its mass, and as told by Dalton that every atom of a same element should have same atomic mass, and the atoms of different elements have different atomic mass, means atomic mass of an element is its fundamental property, which makes one atom different to another, right? So that's why the different scientists were prompted. They started their working towards the measurement of atomic masses of the elements. So today our discussion is based on the measurement of atomic masses, molecular masses and formula unit masses, and how these can be calculated, right? So first of all, here we start with atomic mass. What is an atomic mass? As the name shows, of course, the mass of an atom is an atomic mass. But the question is how to measure the atomic mass. As you see in your everyday life, in order to measure the mass of anything, we need to have a reference. For example, if you go to the market to buy say 5 kgs of apples, then what happens? The fruit seller, he puts a standard weight of 5 kg on one side of the balance and puts the apples on another side and then balances it. That means with reference to a standard balance of 5 kg, you could get the 5 kgs of apples accurately. So if it is the case of measurement of atomic masses, we must have some standard reference. Of course, this reference cannot be in the way as we have in measurement of the masses of apples or anything else, because as you know that atoms are extremely small in size. So for that purpose, we must have some very fine, very minute the reference we should have, and when such reference which we got initially was oxygen 16, right? So in order to measure the mass of an element, two things are required. Not only element, for measuring the mass of anything, two things are required. Of course, first of all, there should be a standard reference, which here in case of atom we have taken as oxygen 16 atom, and the another thing is unit. For example, for measuring the mass of apples, you say 5 kilograms of apple. So kilograms or grams can be used for measuring the mass of an atom, or sorry, of any substance. But as atoms are, as you know, are extremely small, so we cannot use the concept of grams or kilograms. So here for measuring the masses of an atom, we have the unit AMU, which stands for atomic mass. But later on, or atomic mass unit. But later on, IUPAC has suggested. IUPAC, you remember, is International Union of Pure and Applied Chemistry. IUPAC has suggested another unit, that is U which stands for unified mass. So the present day unit for expressing the mass of an atom or atomic masses, we have the unit U, that is unified mass. So as I was already discussing with you that initially oxygen 16 was chosen as a standard reference for measuring the atomic mass of an element. Now you must be wondering, why oxygen only, why oxygen 16 only? Because oxygen was chosen as a standard reference because of two reasons. The first reason is it is quite reactive. So oxygen reacts with almost every element. That's why it was chosen as a reference. And the another reason was that atomic masses of most of the elements with respect to oxygen were found to be whole numbers, right? So for these two reasons, the oxygen was chosen as the standard reference for measuring the atomic mass. But later on in 1961, carbon-12 isotope was chosen as the standard. So in 1961, carbon-12 isotope was chosen as a standard reference for measuring the atomic masses of elements. And now every atomic mass is measured with respect to carbon-12 isotope. So as the masses are with respect to carbon-12 isotope, these masses are known as relative atomic masses, right? So now we have got another term, that is relative atomic mass. So how we define the relative atomic mass? It is defined as the mass of an atom as compared to 1/12 of mass of one atom of carbon-12 isotope. That is the relative atomic mass. So what is relative atomic mass? It is mass of an atom as compared to 1/12 of mass of one atom of carbon-12. For example, if we say that atomic mass of nitrogen is 14U, it shows that one atom of nitrogen is 14 times heavier than the 1/12 of one atom of carbon-12. If we say that atomic mass of sulfur is 32, it means that one atom of sulfur is 32 times heavier than 1/12 of one atom of carbon-12, right? So here we got the standard reference. And now then, what is one atomic mass unit, or what is one unified mass? It is equal to the mass of 1/12 of one atom of carbon 12, right? So that is, in this way we got the expression for atomic masses, and similarly we can explain the molecular mass also. So now how to define the molecular mass? Everything remains same with a very small change. So the molecular mass is the mass of a molecule, right? So molecular mass is the mass of a molecule as compared to 1/12 of mass of one atom of carbon 12 isotope. That means if we say that molecular mass of water is 18, that shows that one molecule of water is 18 times heavier than the 1/12 of one atom of carbon 12, right? So now the question is how to calculate the molecular masses. So numerically the molecular mass is equal to the sum of, it is equal to the sum of masses of constituent atoms in one molecule, right? In this way we can have the term, or we can calculate the molecular mass of a molecule. For example, if you want to calculate the molecular mass of glucose molecule having formula C6H12O6, then we can calculate it as, here we have 6 carbon atoms, each having a mass of 12 unit, plus 12 hydrogen atom, each having a mass of 1 unit, plus 6 oxygen atoms, each having a mass of 16 unit. So it comes out to be 72 plus 12 plus 96, which comes out to be 180 U. So here you can calculate the molecular mass of this glucose molecule. Let's take one more molecule, say having formula CH3CN. So here you can see in the molecule there are 2 carbon atoms. So 2 into 12 plus 3 hydrogen atoms. So 3 into 1 plus 1 nitrogen atom. That means 14 into 1. So this comes out to be 24 plus 3 plus 14, right? So how much it becomes? That comes to be 41 U, right? So in this way you can calculate the molecular mass of a molecule. Exactly in the same way you can calculate the formula unit mass of one formula unit. So now we come to the calculation of formula unit mass. So now it is also equal to the sum of masses of constituent atoms in one formula unit. Now you must be thinking, what is this formula unit? We have never heard about it. Yes. So what is formula unit? You can say it is a molecule in which constituent particles are ions. As a unit, such kind of unit is known as formula unit, right? For example, if we say common salt, sodium chloride, so we wrongly call it to be a molecule. Basically, it is a formula unit, as here the constituent particles are not atoms, these are ions, right? And one thing remember, there is no difference in the mass of an atom and its respective ion. So their masses are same. So here the formula unit of mass of sodium chloride becomes, the ionic mass of sodium is 23, for chlorine it is 35.5, so it comes out to be 58.5 U. Suppose you want to calculate the formula unit mass of ammonium sulfate. So here you can see, now be careful because this all is enclosed in a bracket multiplied by 2, that means it is twice. So here you have 2 nitrogen atoms, then 2 into 14 plus total 8 hydrogen atoms, 8 into 1 plus 1 sulfur 32 plus 4 oxygen, so 4 into 16. So it comes out to be 28 plus 8 plus 32 plus 64. When you sum up, you will be getting the formula unit mass of ammonium sulfate, right? So this is how you can get the molecular mass and formula unit mass by knowing the atomic masses of constituent particles, right? So that is all about today's lecture. In our next lecture, we'll be starting with the very important concept which although starts in class 9th but is very useful for you up to class 12th or even in higher studies. That very important aspect is mole concept, about which we'll be discussing in our next lecture. Goodbye till then. Have a nice time.